Good evening, everyone. This is a re-recording of the original presentation that I gave on Discord in November. The reason why we need to re-record it is because the actual stream recording didn't work, it's lost. So I would go over the presentation once again, and after the presentation I will go over a few questions that were also asked in Discord at the time. The subject of the presentation is the new resource-based APIs that we are developing at the moment in beta, and specifically we'll discuss the Session API. First, let's see about our old V1 API. The old V1 API is a privilege level API with many objects in one API, and it is currently stable, as in we will not make any breaking changes there. We want to reshape our APIs in a resource-based API, where, for instance, the user is a resource, the session is a resource, etc. Hence, that is V2. With level API, we mean that there are different privileges, let's say, different levels of management. So on the lowest level is the system API, where only server level settings can be changed. For example, creating an instance. This is usually only applicable for people that host Citadel. On Citadel Cloud, this API is inaccessible, but we do use it for users that would create a new instance. The admin API manages instance level settings. For example, here is where you can create an organization inside an instance. On the management API, we have organization level settings, for example, create and manage users. On the authenticated API, the current user can manage the settings, for example, update its profile information. Besides the V1 API, which you find here on the right top of the Citadel architecture, we have a login. The login itself is a Go web application with a HTTP server attached to it. Here we have server-side pages, a console, and some static assets. We currently serve a login and register and password resets logic in the Go web app. Besides a little bit of customizations and styling like colors, it is not possible at the moment for our customers to provide their own login. So they will always need to use our login pages. So what does the V2 API bring? It's going to be resource-based, it's going to be object-based life cycles. We have endpoint-based privileges, and currently it's in beta. So let's discuss, for instance, privileges. We would define, or we are already defining, certain management roles in ZITADEL settings, and within such a role there are certain privileges that the authenticated user is allowed to take. For example, there's ERM owner, and ERM owner is allowed to create organizations. He's also allowed to create and delete users inside those organizations. Then there is, for instance, org owner, where org owner cannot delete this organization, but he can still create and delete users. So this is so we still have those permissions as with the original API. They're already used by the V1 API. It's only that now we create other grouping of the endpoints where they are resource-based. At the moment, we have the settings lifecycle user lifecycle, session lifecycle, OADC lifecycle. These are the primary resources we would need to replace the V1 login. And with replacement, we mean anybody could write an application serving a login form and then call this endpoints. Again, so the old V1 login had user registration, hence we need the user lifecycle. So to create and update the user or to reset this password. We need the session so that once the password is checked, we can write the password check into the session. Later, we are currently working on extending the V2 API where, of course, all resources can be managed in the future, but this is a work in progress and it will take some time. So current V2 features, I already touched this for a bit, create an user and set user authentication methods, link identity providers, such as Google or Microsoft, get organization and instance settings, and login users and obtain tokens. So one of the questions we've been getting is, when do we need the session API and when do we use the OADC API? So sessions basically can start empty, and then we can do a username check, we can do an email or a password check, then we can do, for instance, email as a second factor with a verification code, or we could do a web authent verification, and we cycle through that pages of login. So if you look to our current login, we are entering a username. In the new login, we'd make an API call to do a username check. On the next page, there the user could enter his password, then we would call the API and say check the password. And on every iteration of this, the caller of the API will get an updated session token, which is not an access token, but it's a token that basically attaches the session information to the caller. Then once the caller, which might be another server or web application, decides that the user is sufficiently authenticated, it can hop over to the OADC session API and create an auth request and complete the flow by getting a code URL and presenting that redirect to the user so that the user can, or actually the client application can obtain the tokens, the OADC tokens, the access token, an ID token, refresh token, or whatever they require. So let's have a look. Oh, sorry, what I forgot to mention. The session basically is the authentication, and OIDC is authorization framework. So the OIDC stands for OpenID Connect. And here we can see the diagram that is published in the OpenID Connect standards. So here in step 2, this is what we take care of in the session API. Here it says it's one step, actually it's a multi-step process, which is usually outside of the scope of OpenID Connect. So there is authentication happening here with the end user. Again, password, multi-factor authentication, etc. Once this flow is completed, we can give a response to the RP, which contains the token. So let's go over the ORDC flow with the session API. Here we see the customer application on which the user wants to log in. The customer application calls the authorize endpoint on the login UI web app, which proxies the request to ZITADEL. ZITADEL then returns a redirect with an ID, and the proxy serves that to the end user. The end user is then redirected into the login UI where the login flow will start. The login UI would make a RPC call where it will get the current auth request with sanitized OIDC data, such as the login hint and the scopes of the authorization request. Then, during the login flow, the UI would make calls to the sessions API. So it would say post for creating a new session and put on every update, such as check username, check password, request a challenge for email code, fulfill the challenge, so make a code check, etc., etc. After the login UI considers the user sufficiently authenticated, it will call the OIDC auth request endpoint with a post saying we've completed the authentication part of the flow. Then Zitadel gives back a redirect with to the callback of the application. So then the user is sent to the customer app, and the customer app will have a code inside the URL with which it can obtain the token, for example. And after it obtains the token, it can call the user info endpoints or introspection endpoints. As the issuer, the OpenID issuer is the actual domain on which everything is served. The issuer cannot change. The login UI web app needs to proxy all OpenID related requests to the Zitadel backend. So let's talk use cases here a bit. Sessions can work with anonymous user. So for instance, there's a guest shopping cart where the application could start a session without actually doing any authentication. So create an empty session. We could have sessions with username only. Magic link, I included it here in the slide, which was a misunderstanding at the time. I will shortly touch that when we get to questions. Get organization and instance settings is something that we can do now with the resource-based API, and where, for instance, the login wants to know a lockout policy or that kind of things. So let's go over the shopping cart use case. So user comes into a web shop. We don't know who he is. He's not logged in yet. He selects some products and adds it to a cart. At that moment, the application can already create a session. It can actually create a session with an empty request, no data attached. It could also set some metadata if it wants. In turn, the web shop would get back a session token, which it can use for the next update. At one point, the user wants to check out his products, and then he needs to log in, which it might be an existing user, or it might be a user that we need to register. Regardless, we could call the user resource to create the user, or we could directly go to set session if the user was already created with, for instance, a username or username and a password. We can make separate calls. We can do everything in one call. It doesn't matter really. Then when the user is authenticated, we could complete the checkout. We could also complete this with an OIDC flow if we want to get access tokens for later use. That is not specifically necessary, but certainly possible. So let's do a technical example of the session API. Step one, we are going to create an empty session. Here I'm using gRPC URL, which is most like curl. only that it calls gRPC directly. So we are sending here a request with the bearer token, which represents the application user. So this is a machine user path that I'm using here. So I'm calling the create session endpoint with an empty request. Data is empty, is just an empty JSON here. I will get back some standard object details like the sequence of the event, change date, and resource owner of the change. And here, this is important, I get the session ID and the session token. Both of them, I will need them on the next requests. Now I'm going to check a login name of a user. So I'm sending a request to the, where is the endpoint name here? Set session. In the set session, I need the session ID and the session token that we've retrieved from the last call. And the checks that we are doing is login name, roberts@demo, and this is my instance. Again, we will get back the standard details of sequence, change date, etc. The session token is changed. So on every update of the session, you get a new session token, which has to be used again on the next call. The old session token will no longer be valid. So now we are going to do a password check. Session ID, updated session token, and here checks password. Similar type of response, again a new session token. And now we are going to do something else. We want to challenge a email one-time password, email OTP. So basically we call the session endpoint, but this time with challenges instead of checks, and we say we want OTP over email, please send the code. There are more options here, like we can even return the code to the calling API, to the API client, where the API client can send the email themselves. But in this case, we are asking ZITADEL to send the email for us with send code. Again, standard response, update the session token. In the background, the user would now get an email with the OTP code. So on the next step, we would check that code. So we are back into doing checks, OTP email, and this is the code that the user entered after they received the email. So when everything is done, or even in intermediate stages, we can always call get session. Get sessions will show us the current state of the session. Again, session ID and the last session token that we received back. The actual response doesn't fit this screen, so I'm just gonna show it right here. Here we have the creation date of the session, change date, the current sequence. Oops. The factors that were checked and authenticated. So we have, for instance, the user was verified at this timestamp with this ID, where the user has this login name. This is his display name that we can use in the UI. And he is part of this organization ID. And then we see that the password was verified at this date and the OTP email was verified at this date. So that's the state of our session in that case. The client application in this case can say, okay, we have three factors authenticated. This is all we need, and it could now complete the OIDC flow, for instance, and then also in the OIDC flow, the claims would reflect that there were multiple factors used. So much for the presentation part. I've written down some of the the questions that came in and confusions. So let's start with the magic links. Magic links, as some people might consider magic link like a QR code that users can use to log in, like for instance Discord does. This is not really covered yet by the APIs. This is more a device authorization thing. We do support device authorization at the moment on the old login. When the device authorization endpoint is called, you get a URL to which the user can be redirected. You could create a QR out of that URL, which the user can then scan and log in, and etc. So we have that in V1. Of course, this would need to be ported to the V2 as well. Then we had a question about the proxy. Does the proxy already exist? Actually, it does. So does the new login, which is still in a, let's say, work in process state. But we have this TypeScript repository. And the TypeScript repository would be the place where we are developing the new login. This is a Next.js web app. The Next.js web app itself will include the proxy. And we will give a hosted login just as we've been doing right now. With the other benefit that anybody could implement their own login if they want and just call the APIs. They could fork the repository and create something out of that. That's all possible. Connected to that, we got a question, will we have UI components for that? Actually, we will have. Myself, I'm a backend engineer. I wouldn't know how to explain that, but the whole new login will be implemented in components that are reusable should you want to implement your own login. Can we enable other factors in the Session API? Yes, we can. As a matter of fact, we discussed here OTP email, but at the moment we support WebAuth and we support SMS OTP passwords, we support time-based OTP. I think that's about it. I think that is all we can say about that. We currently have a discussion open regarding the user schema. The user schema is something we want to make more flexible for our customers in the future. At the moment, there's still user information which is hard requirements like email or name, display name or whatever. And we get more and more feedback that not every business case needs those fields enforced. At the moment, they're enforced because the ZITADEL logic is depending on it, but in the future, we want to go to a more liquid state where our customers can specify a certain field which is required for authentication, like a username or a phone number even, and then optional fields, or at least optional from the point of view from ZITADEL, but they might be required from the point of view from the customer. So we are going to design a system where all of those specifications can be specified by the customer. Basically is the issue 6433 on GitHub. It's already a lengthy enough discussion, but for people who haven't heard about it, this is the place to be for that. I hope everything was clear. If there are still questions, you can always reach out on Discord, and we'll try to answer those questions as soon as we have some time for that. Have a good evening.